Okay, good morning students. So today we are going to have continuation of our lesson, projectile motion. The lesson purpose is to describe changes in physical quantities during the movement of the body thrown at the angle to the horizontal and vertical. As you see in the pictures, this motion we see almost every day. So, it's correct. So in real life, one-dimensional motion which we described in our previous lesson is like apple falls from tree, car drives on the straight road, but there are many two-dimensional motions such as car drives to work, ship sails to Europe, and also we are playing football or basketball, so we're experiencing in every day. Do you experience in every day playing football or basketball?
Yes.
Good. So my question is, what is projectile? Yes, please.
This is an object that, because of its mass, moves along a spatial line.
Okay, good. What else? Who else? Do you have any? Okay. Can you please read what is projectile?
Projectile any object which projected by some means and continues to move due to its own inertia, mass.
So, what is mass? Well, that's inertia. We know from the Newton's law. So here we'll consider three options. First, horizontal projectile, like the ball we drop, and then vertical projectile, which you do every day playing basketball, and the general case when we play the ball thrown on the horizontal and vertical dimension. Okay, good. So projectile move in two dimension. Why we do in two dimensions, guys? Why?
Because we exert the motion in the x, y,
X and Y
x and y space.
Okay, good. Yes, exactly. So, since the projectile moves in two dimensions, as said, it therefore has two components, just like a resultant vector. So, can you please help me to draw the line X and Y? Here. What is X and what is Y?
The x is horizontal line and the y is vertical line.
Exactly. Horizontal and vertical. Very good. So let's consider horizontal velocity component. Well, horizontal velocity component is, what is line of horizontal? What is axis? X or Y? X. Okay, good. And as you see here, never change. Can you please say?
Never change, the cover equals displacement in equal time periods. This means the initial horizontal velocity equals the final horizontal velocity.
As we see here, time in equal time, equal distance. In other words, the horizontal velocity is constant, but why? Can you? Because of? Any suggestions?
Because of the in the equal time, the subject is do the equal distance. In the equal time, equal distance.
You're almost correct, because gravity does not work in horizontal, and that's why the V is constant. Okay, very good. So now let's check this vertical velocity component. So as for vertical velocity, so can you please tell me, do we experience any differences against the horizontal movement? Well, let's find out. Can you please tell me?
Changes due to gravity does not cover equal displacements in equal time periods.
Exactly. So both magnitude and direction change. as the projectile moves up, magnitude decreases and its direction is upward. And it moves down, the magnitude increases as we see here, and the direction is downward. As we see that the vector is changing the directions. Okay, good. So let's combine and check what we have. So what is the trajectory of this movement?
These components produce what is called a trajectory or pulse.
That is
Parabolic.
parabolic in nature. So let's see separate components, magnitude and direction. As for components, we have horizontal and vertical. Magnitude is constant, and as for vertical is changes. Let's combine the components. So what is the trajectory or path for this motion, please?
This pulse is parabolic in nature.
Okay. Let's check these components by magnitude and direction separate. Okay. So what about horizontal?
The magnitude of horizontal motion is constant, and the direction is also constant.
What about the vertical, please?
Vertical, where magnitude changes and directions also change.
To solve this problem, let's write it down what we have. So what do I know? We know initial velocity, which is
100 meters per second.
okay. So we know the height, which is okay. So initial velocity on vertical is 0, and the gravity constant is, acceleration of gravity is, let's consider 9.8, and we need to find time and coordinates. So the initial formula is y is equal gt squared divided on 2. So we have all these components where we can put it down and to see how much it will be. The time will be 10.1 seconds, and the distance will be 1010 meters. So vertical launch projectile. So in this case, we see that there are two components, which is, what components do we have? What components do we have?
Horizontal and vertical.
Okay.
Horizontal and vertical.
Okay. So what about the horizontal magnitude and direction? Please.
If we talk about horizontal component, its magnitude and direction will be constant.
About the vertical component, what about the vertical magnitude and direction?
The vertical magnitude is decreased up to 0 and increases down, and the direction is vertical, is changes.
Decreases up to 0, so at the maximum point or at the maximum height, the velocity will be 0, with slow increasing downwards. Velocity decreases on the way upward, but why? Can you tell me? Why velocity is decreasing? What force it experiences? Yeah, gravity is forcing to the subject. Все, начинаем.
Because the gravity is acting the subject, so the velocity will be decreasing.
Good point. Velocity vertical increases on the way down. As you see here, I want to point your attention that no vertical velocity at the top of the trajectory. Is it clear? Okay, is it well understood? Yeah, okay, good. So, since the projectile was launched at the angle, the velocity must be broken into the components. So, as we see here, the vector of velocity placed on the trajectory movement. So, we break down into two components, which is horizontal, and another is vertical. Since we have horizontal and vertical components and the angle, so the V0 or V initial x is V0 on cosinus theta. As for V0 y, V0 sinus theta. Well, I well known from your math course. Good. So, vertical launch projectile. Now there are several things we must consider when doing these types of projectile besides using components. If it begins and ends at the ground level, which is here, the y displacement is 0. Y equals 0. Displacement is 0, but the trajectory is certain length. Okay. We will still use kinematic number 2, but you must use components in these equations such as V0 cosinus theta, which displays this Vox, and VO sinus theta, which displays vertical speed, vertical velocity. Let's check the example. Can you please read the statement of the problem?
A placekeeper kicks a football with a velocity of 20 meters per second and at the angle of 53 degrees. How long is the ball in the air? How far away does it land? How high does it travel?
Okay, can you please open your notebooks and solve this problem? Let me explain to you. So, V0x is V0 cosinus theta, which we know the degree, and V0x, you need to just to put this data on this formula. As for V0y is 0, V0 with sinus theta, which putting the numbers, you can get the initial parameters, Vox and Voy. And now let's see how long is the ball in the air. Okay? So who wants to solve this problem here at the blackboard? Any volunteers? Can you please? Okay. See what here, please. Dano. So what you know, we have Vox, which is 1204 meter per second. Okay, Voy 15.97 meters. Okay, what else? G, acceleration of gravity we consider as 9.8 meter per second square. So what I want to know is the time and the distance, horizontal distance, and y max, the height. So what's your step in solving this problem? Да, скажи, which is, huh?
We find y. Y is equal y initial t plus gt square divided 2.
Okay. So you need just to put the data. So So, which is equal?
3.26 seconds.
Second. Okay, very good. Thank you. Well, as you see here, it's 3.26, which we already found. And now, the next one is how far away does it land? So, any volunteers? Please.
The x component I can separate, and x is x equals v of x, which we have 12 and 4 combine and multiply to the result that also t did. Just t. So we have 4.4 and combine 12.04 multiply on this result, we will have
Which is in
n meter.
meters. Okay, good. Does it travel? Fine. So, and the last component, how high does it travel? Any volunteers? Please.
Meaning inside it, outside this scope, and we will get and in conclusion we have the result is equal y is equal to 13.01 meters.
Well done. So, as we see here, we solve this problem in this example, and we have to calculate 3 parameters. Well, do you have any questions in terms of for this problem? Any questions?
No.
Is it clear?
Yes.
Is it well understood?
Yes.
Good. Well, let's do formative assessment on this subject. So let's play quiz. Do you have your mobiles? Can you please? And I'm going to send you the link for this quiz. So quiz, there are 7 questions. Please try to make it in maximum 5 minutes. Okay? When you register, put your name, only names. No nicknames, just names. Okay, I'm going to give it to you. Okay, please follow the link. So, let's proceed. Okay? Are you ready? Okay. Let me see. Well done, your accuracy is 92%. Try not to make mistakes. Well done, please carry on. So let's see. So the first place is Camilla, the second is Oljas, and the third is Mansour. Well done. And let's see the score. So what we do, next lesson we do the feedback of this given lesson. First I have to check the results, but in general, good. So at the end of our lesson, I would like your feedback. Any questions? Do you have?
No.
So what do we learn in this lesson?
Projectile.
Okay, projectile, which is?
Any object that we throw with.
Continue to move.
Yes.
Continue to move
Like parabola.
like parabola, okay? And can you tell me what is kinematic equation Number 2.
The x is equal to xo plus velocity initial x multiplied time plus 8 multiplied 6 squared divided by 2.
Why we consider this parabola trajectory and we divide it into equations? Why? Because we have movement on horizontal and vertical.
Yeah.
So what is formula for horizontal movement? Any volunteers? Please what?
Velocity Ox t.
We have this formula. Is any influence of gravity there?
Yeah.
No.
No influence, okay. So do you have any further questions?
No.
Is it clear? Is it understood? Okay, where do we feel in this diagram?
I understand.
Well, if it's like that, give me your thumbs up. Okay, thank you very much, and thank you for your participation, and have a nice day. Thank you, and bye-bye. Bye-bye.